Okay, lesson 2.3, proving theorems. Now, this chapter 2 is a lot of proofs, a lot of trying to get you used to doing proofs. But as we move on to subsequent chapters, there's a lot of other things besides proofs. So, as I keep saying, let's just do your best to understand proofs, and usually by chapter with congruent triangles, that is chapter 4, proofs will start to click. So I just want to keep you guys from panicking. All right, so lesson 2.3, proving theorems, just has a couple new theorems that we haven't. We'll keep getting new theorems all along. Every theorem can be proved. We're not going to prove them all, but they all can be proved. So I'm going to only prove 2.1 in this lesson just because of time. I want to do some more practical exercises with you in this lesson. So the midpoint theorem says if M is the midpoint of AB, so here you can see M is the midpoint of AB, then AM is half of AB, and MB is half of AB. Now, previously, I don't know if you remember this, hopefully it's copied into your definition section of your notebook. The definition of midpoint says that M is the midpoint of AB, then AM equals MB. Just a slight difference, but a definition doesn't need to be proven. It's just taken as true. The midpoint theorem, on the other hand, is a theorem, so we're going to prove it. So let's just give this one a try, just another opportunity for you to see how proof is done. So remember, what do we write on this line? We write the given. M is the midpoint, and I'm going to use MP for that, of AB. And it's segment AB. I don't have a thing to write a line on top of these segments. And the reason for that is given. Everyone can do that. Okay, what we're trying to prove is AB is half of AM is half of AB. So just follow along. If we know M is the midpoint, what that tells us is that AM equals MB. Now that's just the definition midpoint, which I said before. Now there's two different things here, so just try to keep track of them. The definition midpoint just says if a point is the midpoint, it divides it into two, equal or congruent. You could put equal or congruent on this line, but I'm going to use equal because do you see how we have this 1/2? 1/2 is a number, and when we're dealing with numbers, we're going to do equal, not congruent. All right, so we have that first. We can use our segment addition postulate, which we use all the time. AM plus MB equals the whole big long thing, AB, and that's our segment addition postulate. Segment addition postulate. All right, now, because AM and MB are equal, we can replace this MB right here with AM. So we're going to get AM plus AM equals AB. I just did a substitution. See how I substituted? AM is equal to MB, so instead of writing MB, I wrote AM. And that's just our substitution. Property of equality. And then we can add these together, so we get 2AM equals AB. See where we're going here? We're going somewhere, yay. And that is just going to be the, addition property of equality. Okay, property of equality. And then we're going to divide both sides by 2. And that's going just to be our division property of equality. And I think we did it. MB, is that one of the things we're supposed to do? AM, yeah. And then we would just do it the same way. We would just substitute differently. We would have substituted, instead of having 2 AMs, we would have 2 MBs here to get the other one. So this is the division property of equality. All right, we're going to skip the next example. It doesn't really help you with the homework, but this is the thing you need to memorize, that when you're using the midpoint theorem, that it's going to be half. Each of the segments are half of the longest segments. So let's move on to there's another theorem. This one is exactly the same, except it's angles. So if BX is the bisector of angle ABC, then ABX equals 1/2 of angle ABC, and the measure of angle XBC equals 1/2 the measure of ABC. So this proof is exactly the same as the last one, except we're dealing with angles. So I'm just going to draw this one in real quick. So we have a line, we have another, these are rays. They're rays because they are going to have arrows at the end of them, and they originate from a point. So I'm going to put the arrows on them like this, this, and this. And this is going to be B. We can just talk through this proof briefly. A, X, and C. All right, so this theorem is saying if BX, this one right here, is the bisector of ABC, then we know that each of these little angles are equal to half of the big angle. And we would prove this by saying, you know what, this is, since it says it's the midpoint or the bisector, these are going to be congruent, right? And then since they're both the same, we can add them together and divide by 2, and it's going to be half of the big one. So it's the same as the midpoint one, only it's with the angles. And remember, we would be able to say that ABX is equal to angle XBA because of the definition of angle bisector, which says if a ray divides an angle in half, each parts are going to be equal. So that would be your angle definition of angle bisector. If a ray bisects an angle, it divides it into 2 equal segments. All right, I'm going to go right to the homework. I don't want to spend any more time doing these proofs. You're going to have proofs to do, but believe me, it's not going to be the main part of any test. It's just something that we really want you to be able to do by chapter 4. All right, so let's go to I'm going to go to the classroom exercises first. So let's work through these, and then we'll do some of the writtens. This is kind of like the lesson that we're going to do. And then you guys will do the written exercises. It says, what postulate, definition, or theorems justifies the statements about the diagram? Now, that's why you have a little notebook of postulates, definitions, and theorems, so you can look through them and figure out which one it would be. So I'm going to help you out with these classroom ones. So this one says the measure of angle AEB plus the measure of BEC equals the measure of AEC. So this is the case where you have 2 smaller angles add up to the bigger angle, and this is your angle addition property. Angle addition property. All right, next one, you have AE plus EF equals AF. So this should all kind of be a review. We've been using these in proofs, but they're just trying to get you used to being identify what is going on. So here we have 2 segments that add up to a bigger segment, but all the 3 points lie in the same line. So this is the segment addition property. All right, now we have angle AEB plus measure of BEF add up to 180 degrees. And that's your angle addition postulate. Now, if you look back in your book at the angle addition postulate, it has 2 parts. Postulate. Yeah, this should have been a postulate here instead of a property. Postulate. You wouldn't get it wrong if you did that. Angle addition postulate, which says if you have 2 angles with a point in between that make the 2 angles, then if you add on the same straight line, then they're going to add up to 180 degrees. And that's what we have. We have AEB, where B is the point in between. BEF, these are on the same straight line. Later, we're going to talk about how they're linear pairs. When they share a side and they're on the straight line, they add up to 180 degrees. That's the angle addition postulate. All right, let's keep going. If E is the midpoint, here's E, midpoint of AF, then AE is congruent to EF. And that's a definition of midpoint. Remember, the definition of midpoint says that if a point is a midpoint, it divides a segment into 2 congruent or equal parts. That's different than the theorem. The theorem is the AE would be half of AF. So this is the definition of midpoint. And the next one is if E is the midpoint of AF, then AE is half of AF. That's the one we just learned in this lesson. That's the, that is theorem, let's see, I'm just thinking how to say this. This is the midpoint theorem. Midpoint theorem, opposed to the definition. Theorem. All right, number 6. If E is the midpoint of AF, then EC bisects AF. So let's look at this. If E is the midpoint, then ray EC bisects AF. So this is just the definition of bisector. Bisector. Number 7, it says if EB bisects AF, then E is the midpoint of AF. So this is just this one in reverse. They're the same thing, so it's just the definition of bisector. They're just flipping the definition around. One starts out with a bisects, it's a midpoint. The other one's a midpoint, then it bisects. All right, E8. If EB is the bisector of AEC, then measure of angle AEB is 1/2 the measure of angle AEC. And this is the same. Remember the midpoint one up here where we use the 1/2? If you use the 1/2, then it's going to be the angle bisector theorem opposed to, you guys can write neater on paper, opposed to the definition. Number 9, if angle BEC is congruent to CEF, then EC is the bisector of BEF. So this again is the, it's just going to be the definition of angle bisector. If it has 1/2 in it, then you would know that it's going to be the theorem. All right, let's do this little proof, and then I'll just talk about the written exercises. So it says, this proof, it says BX is the bisector of ABC. So here's BX, it's the bisector, so we can we can mark up our diagram. So we know it's the bisector. We're going to prove that ABX is half of ABC. So we'll just do the first part because the second part will be the same thing, only we would have to put in the different letters. So BX is the bisector of angle ABC. Now that's right here, so given. So they would say angle ABX is congruent to XBC, right? XBC, or it equals the measure of angle XBC. You can use either one. But since we're going to be adding them, we need to use the equal. So the next one is the measure of angle ABX plus XBC. ABX plus XBC equals ABC, and that's your angle addition. Whoops, I didn't write the reason for this. It's just the definition of bisector, right? Angle bisector, because it's just saying that they're equal. Sorry, sometimes this thing just does its own random thinking because I'm doing this on the internet and sometimes it gets slow. All right, so this one here, we have ABX plus XBC equals the measure of ABC, and that's just your angle addition or definition of, no, angle addition postulate, sorry. Postulate. All right, because we're adding the two small angles and getting the big angle. Now we can say the measure of angle ABX plus the measure of angle ABX equals the measure of ABC. Now up here, when we set this step right here, we're saying that these two angles are congruent. So where there's a XBC, we can put the ABX right there, the ABX, because they're congruent. So I'm just substituting the equals in, and we're just taking this, since this is equal to this, I can replace this with this, and that's just substitution. All right, and then they just went ahead and added those two together without putting a step. Great for us, huh? So I would put addition postulate in between here because we're adding two measures, measure of angle ABX, and the measure of angle ABX is 2 measure of angle ABX. And then we're just dividing both sides by 2. So this is division, property of equality. And I should write that the same way I've been writing them before. PO, division, property of equality. And this one here is the same thing, only instead of substituting A, B, X in for X, B, C, we're going to put A, B, C, I can't read my writing there, X, B, C in for this one right here. So we would have two XBCs. So hopefully you got that. It's a little tricky, I get it. All right, let's go on to the last page that I have. And this is what you're doing for your homework. It's probably too late. I apologize for getting this video in late. This is the same thing as what we did in the classroom exercises right here. So we'll try to do more classroom exercises in class so that we can get, because they're somewhat similar to the homework. So you're just going to pick which definition, postulate, or theorem goes with each of these. So you can check your answers. You can check them on the Slater. Even though I'm still having trouble like seeing full solutions, these you can definitely see. Look at the answers and work your way backwards to understanding it. All right, these say write the number that is paired with the bisector of angle ADE. So they want you to know it's a bisector, so that these are going to be the same. So you find the distance. I'll do this first one. You're going to find the distance between these 2 points. So from 40 to 80, it's 40 degrees. So that means the middle one is going to be, if we divide that in half, it's going to be 20 on each side. So 40 plus 20, this one's going to be 60 degrees right there. You're going to do these. You're going to subtract them, divide them by 2, and then add it on to the smaller one. Same thing there. All right, these are fairly self-explanatory, so give them a try, do your best, check your answers, and we'll go over any more that you don't get from here on down in class tomorrow. So that's it for lesson 2-3.